There have been several questions from section 12.1 and 12.2 that I do not feel like the book gave that good of an examples to show you exactly how to work these types of problems. So I wanted to create a video lecture to maybe help you with some of these if you're struggling with these in 12.1 or 12.2. And so the first type of problem we have are these composite figures. And we are asked to find the area of each composite figure. Okay, and you will find one similar to this in your section 12.1. And it says all curves are circular arcs with the centers shown, okay? And so that means that for this circular arc or this curve, this is the center, okay? And so it also says to round our answers to 2 decimal places. So I can see from this composite figure that is made up of a semicircle here, a trapezoid in the middle, and a larger semicircle on the bottom. And so if I wanted to start this problem off, I would first write down what made up that composite figure. And we said it was 2 semicircles. Semicircle is half a circle, plus a trapezoid in the middle. Okay? And so I'm going to start with that top trapezoid. Top semicircle. Okay? And so we're finding the area, and I know that the area of a circle, if it was a full circle, would be area equals pi times radius squared. Now, I have provided in Canvas, and I believe I sent this out as an attachment in an email or emailed you regarding this formula sheet, but I gave an updated formula sheet that it has more specific formulas. And so if you have not run this off and made a copy of this for you to use, you can use this on all of your homework and tests. You need to do that, because if you're not familiar with these formulas, then you will have this as a reference. You can use this on your test as well. Okay, but back to our problem. So an area of a regular circle, full circle, is pi times radius squared. But we're talking about a semicircle or half a circle, so our formula will actually be 1/2 times pi times radius squared. Now, if we go back to our drawing, since this is the center and all of this whole entire line from here to here is 6 centimeters according to that drawing, then that means the radius of this would be half that, or 3 centimeters. So that is what I'm going to put here for my radius. So the area of that top semicircle will be 1/2 times 3.1416. Notice that I'm using a little bit more specific decimal for pi other than just 3.14, times our radius we said was 3, so 3 squared. And so I would just type that into my calculator as 0.5 times 3.1416 times 3 squared, and you should get that gives you 14.1372, and since this is area, that would be square centimeters. Okay, so then looking back at the drawing, I see that the middle part was a trapezoid. So next I'm going to find the area of the trapezoid in the middle. And again, go to your formula sheet if you do not know your formula for area of a trapezoid, but it is area equals 1/2 times the sum of the 2 bases times the height of the trapezoid. So that's going to be 1/2, and if we look back at this drawing, since this top part is 6 and this bottom part here is 9, those are my 2 bases, and the 2 there that's perpendicular to this 9 centimeters is my height. So my 2 bases are 6 and 9, my height is 2. And so I'm going to plug that into my formula. So that'd be 1/2 times 6 plus 9 times my height, which is 2. Well, this 2 and this 2 reduce, so it's really just 6 plus 9, which is 15 square centimeters. Okay, and so then we had the bottom semicircle, and we're going to find the area of it. And again, we're going to use the same formula as we did for the top semicircle. Since it's half a circle, we're going to do 1/2 times pi times radius squared. So that's going to be 1/2 times 3.1416 times, and if we look again back at our drawing, we have that all the way across here, the diameter of this semicircle is 9, so that means the radius from here to here would be half that, which would be 4.5 centimeters. And that's going to be squared. That's my r squared. And again, I would just type that into my calculator as 0.5 times 3.1416 times 4.5 squared. And that is going to give us 31.8087 square centimeters. So to find the total area, I'm going to add all of my individual pieces here, each area of each part of the composite figure together. So that would give me an area of 14.1372 plus 15 plus 31.8087 square centimeters. And when I add all of that together and you round it to 2 decimal places, you should get 60.95 square centimeters for the area of that composite figure. Final answer. Moving on to the next part of this problem, we again have a composite figure, same directions, find the area, and this time I see the top part is a semicircle, half a circle, and the bottom part is a triangle. So I'm going to begin by writing that on my paper, that my composite figure is made up of a semicircle plus a triangle. And we're finding the area. So let's start with the top semicircle. And since it's a semicircle or half a circle, then my area will be half of pi times radius squared. If it were a full circle, it would be pi times radius squared, but since it's half a circle, we're going to put that 1/2 there. And looking back at the drawing, I see that all the way across here is 8.2, so that would be the diameter of that semicircle. I need the radius from here to here, or half of 8.2. Well, if you do 8.2 divided by 2, you're going to get 4.1 for the radius. And so that's what I'm going to plug in for r. So 1/2 times 3.1416 times 4.1 squared. And again, I would type that into my calculator as 0.5 times 3.1416 times 4.1 squared. And that is going to give us an area for that of 26.405148 square meters. Now let's look at the triangle. And the area of a triangle, again, use your formula sheet if you need it, is 1/2 times base times height for a triangle. So let's look back at our drawing, and I see that this triangle has a base of 8.2 and a height of 7.6. So I'm going to plug that into my formula. 1/2 times 8.2 times 7.6. And again, I would use my calculator, 0.5 times 8.2 times 7.6. And that gives me an area for the triangle part of 31.16 square meters. So now to find the total area, put the two together. Add these two individual areas together. So that's 26.405148 plus 31.16 square meters. If I add that and round it to 2 decimal places, that gives me an area of 57.57 square meters for the composite figure. Final answer. Okay, still working in section 12.1. This is finding the perimeter this time of a composite figure. Okay, and so this looks like that we would have a, nice trapezoid here, except for we have this little curved part here. And so we cannot just add all the sides up until we know what this arc length is, okay? So this is called an arc here because it's curved, okay? And it tells us in the directions, and this is important, all curves are circular arcs with the centers shown. So in other words, if I could draw the full circle that this piece is from, and draw it, extend it on around, they're telling me that this from here to this would be the center of this overall circle that we're getting this arc from. And so if we look at the drawing, let's go ahead and label what we can. Always look at your markings when you are given a figure. Double markings here and here mean that this is 7 millimeters, so this from here to here is 7 millimeters. This side is 9, this has single markings, so this side is also 9. From here to here is 13, it has triple markings. This side from here to here has triple markings, so that tells me from here to here is also 13. Now notice that this line here, dashed line from here to what would be the center of our full circle, has the same single marking as this. So that tells me that if this has a single marking and it's 9, then they're telling me these two dashed lines are also 9. Now, I know that as far as everything with this curved part, to find the perimeter of a figure, I simply add the sides up. So I know that I'm going to add 7 plus 7 plus 9 plus 13 plus 13 plus 9, but I've got to figure out how do I find this arc length. And so again, if you have run that formula sheet off, okay, you will see that on the second page, the formula for the arc length of a circle is given. There are two different formulas. I'm going to use this top one. And it says the arc length, that means this, in other words, normal circumference, which is the same thing as finding the perimeter of a circle, goes all the way around. But if you want just a piece of the outside part or an arc length, this is the formula we have to use. And it says theta divided by 360 times 2 times pi times the radius. Well, what is this theta? This theta is called our central angle measurement. And so if you know that, then you divide that by, there are 360 total degrees in a circle, times 2 times pi times the radius, and that's going to give us the measurement of just this arc. So now I'm going to take and I'm going to work on finding that arc length. Since the rest of it is just simply adding the sides up, let's focus on finding the length of this curved part, this circular arc. Well, basically they told me that from here to here is the center. So basically what they've given me is that the radius of this overall circle, if I could extend this out and draw the full circle, would be 9. So I know the radius for this arc length is going to be 9, and I also have my theta. My central angle measurement is 44 degrees. So if I take that formula for arc length of a circle, which is theta divided by 360 times 2 times pi times the radius, not plus, but times, and I plug in 44 degrees divided by 360 times 2 times 3.1416 for pi times my radius we said was 9, then I can get my arc length, or the piece here that's curved, and then I can add all the rest of my sides up plus this arc length, and I'll have my perimeter of the overall figure. So again, if you're going to use your calculator, you must put parentheses around this fraction. So you would type that in as parentheses 44 divided by 360 close parentheses times 2 times 3.1416 times 9. And so that gives you an arc length of 18.8496 centimeters. Okay? Now for the rest of it, again, we're just going to add all the rest of the sides up. Now we know this piece is 18.8496. We're going to add 7 plus 7 plus 9 plus 9 plus 13 plus 13 plus what we just found to find the perimeter. So the perimeter would be 7 plus 7 plus 9 plus 9 plus 13 plus 13 plus that arc length, 18.8496 centimeters. Perimeter is a linear measurement, not square centimeters, that's area. And so when I add all of that together, I get that we have a total arc length. I'm sorry, I think I gave the other problems arc length here. Let me go back to this for just a second. I'm sorry, this is supposed to be, I was given part B there. Parentheses, so if you've typed that in, 40 parentheses 44 divided by 360 close parentheses times 2 times 3.1416 times 9. I'm sorry, this was not the correct arc length. That was for part B that we're about to do. The arc length should have been 6.91152. Okay, so, and that would be millimeters. I was looking at the second part problem. So excuse me, go back to this. So when you do 44 divided by 60 times 2 times 3.1416 times 9, you get this for the arc length. And then all of this is still the same, plus, now let's add 6.91152 millimeters. And then when we add all of this up, we get the total perimeter and round it to 2 decimal places of 64.91 millimeters. Okay? So that was for this figure here. Now let's look at part B. Part B looks to me to be basically, you know, 2 arc lengths here and here that are equal because their central angles are the same, 120 and 120. So when I know one of these, then I know the other. And then across here, I've got 9, and I know that this would be 9, and this would also be 9. Now let's talk about how I know that. Well, again, these centers are shown. This is the center. And so if from here to here is 9, then if this is the center, then from here to the another point outside, on the outside of the circle, or on the edge of the circle, I should say, would have to be 9 as well. This would have to be 9, and since these two are the same as this is 9. And again, since this is the center, then from here to here, and since this is the same as 120 here and 120 here, then this is 9, this is also 9. So you've got 9 plus 9 plus 9 across the bottom. So let's work on the 2 semicircles. And again, we're finding the perimeter, or the distance around this composite figure. And so we've really got 2 arc lengths to find here with a central angle of 120. So when we find one, then we just can say times 2, because this other one will be the same as this. These 2 arc lengths will be equal. So going back to your formula for arc length, again, that's on that formula sheet. If you've not printed that out, you need to do that. Theta divided by 360 times 2 times pi times radius. And our theta this time is 120 degrees divided by 360 times 2 times 3.1416 times, now let's talk about that the radius of this, either from here to here, or it's the same thing as from here to here, would have to be 9. So R is 9. And again, if you're going to use your calculator, you must type this fraction here in parentheses. So parentheses 120 divided by 360 times 2 times 3.1416 times 9 should give you an arc length of 18.8496 centimeters. Now remember, we have 2 of these that are equal. And so if I double what I just found, so 2 times 18.8496 centimeters, that means the 2 arc lengths would have a measurement, or a perimeter, of 37.6992 centimeters. Now, if I go back to my drawing, so what I have just found is this arc length and this arc length, and that was 37.6992. 27.6992. Then I just add 9 plus 9 plus 9, or that's really plus 27 to go across the bottom part of this. So I'm going to add that 27 centimeters across the bottom. And so our total perimeter for this problem, and round that to 2 decimal places, would be 64.70 if we round to the hundredths place centimeters. And again, that was for this composite figure here. Okay, so the next thing that I want to show you is still from section 12.1, and it's a fountain question. It says the fountain below is made up of 2 semicircles and a fourth of a circle. So 2 semicircles, that's really 2 half circles and a fourth of a circle. It wants the perimeter and the area of the fountain. Round your answers to 2 decimal places. Okay, and so we are to assume again that this semicircle, this would be the diameter of this semicircle, which is the same thing as this semicircle. So both of these are the same, and this part is the fourth of a circle that they're mentioning in the directions, okay? So let's just again start by writing on our paper for this fountain question what makes up this drawing. And this drawing is made up of 2 semicircles plus a fourth a circle. And let's start with the perimeter first. Okay. Well, if these were full circles, then the perimeter of a circle is the same thing as finding its circumference. But since this is only half, since it's a semicircle, let's focus on this semicircle here, which we know will be the same as this one here. So if I wanted to find the measurement from here to here of this semicircle, then what I would do is I would do half my circumference if I had the whole thing. In other words, I know that the circumference of a full circle is either 2 times pi times the radius, but since we're given the diameter, which goes from this edge of the circle to the other edge all the way across, we're given the diameter, I'm going to use pi times diameter. But since it's a semicircle, this is what we're focusing on right now, I'm going to have to do half of that amount. And so that's going to be 1/2 times 3.1416 times my diameter, which is 8. And so the circumference, which is the same thing as the perimeter of this semicircle here, is going to be, if I type that in my calculator, 12.5664 meters. But remember, we have 2 of these semicircles that are exactly the same. So that means that I'm going to go back and double this. So 2 times 12.5664 meters means the circumference for the 2 semicircles. And by the way, if you put 2 semicircles together, you really have the full circle. So that would have been another approach to it. But so if I type that in my calculator, I get that the 2 semicircles together have a perimeter of 25.1328 meters, or circumference. Now let's focus on, so that was the 2 semicircles. Now let's focus on, that was the 2 semicircles that we just worked here. We said the 2 semicircles have this perimeter, or this circumference. Now let's work on the fourth a circle. Okay? So again, circumference is pi times diameter, but since we're doing a fourth of a circle, we're going to do a fourth of the pi times the diameter. Okay? Now we have to use a little bit more reasoning here on this fourth of a circle. This would be a much larger circle. Since this is only a fourth of the circle, then these semicircles, we could definitely see that we're going from one edge of this semicircle to all the way across. So we're getting the diameter of this semicircle. But what we have here for the 1/4 of a circle part is not the diameter, but rather this from here to here. This time the 8 meters for this 1/4 of circle part in here, this is the radius. So this is R for this 1/4 of a circle part, okay? And so I'm going to do, if I know the radius is 8, then the diameter would have to be 2 times 8, which is 16. Okay, so I'm going to do a 4 times 3.1416 times 16. Now 1/4 I know is 0.25 times 3.1416 times 16. And so the 1/4 of circle would have a circumference or a perimeter, in other words, of 12.5664 meters. Okay, when you multiply 0.25 times 3.1416 times 16, this is your circumference. Okay, and so now I need to add that to the 2 semicircles. So if I add these 2 together, the perimeter of the fountain would be final answer rounded to you get 37.6992, but if I round that to 2 places, that 69 is going to go up to a 70, and that's going to be meters. So the perimeter of the overall fountain is 37.70 meters. Okay? Now, that was only the first part of the question. We found the perimeter of the fountain. Now we need to find the area. So now I'm going to use my area formulas, but remember these are semicircles and a 1/4 a circle. Okay, so area, again I have 2 semicircles, which are half a circle, plus a 1/4 a circle. So I go to my area formulas for a circle. Well, I know the area of a circle, so we're going to start with the 2 semicircles first, is pi times radius squared. Well, for our semicircle, if you go back, that's these 2 parts. This is the diameter of the semicircle, so the radius halfway from here to the center would be 4. So I'm going to do 3.1416 times 4, and again, because these are semicircles, we're going to have to put this 1/2 here in front of it. Okay, because this piece here is only half of a circle. So I'm going to have half of 3.1416 times 4 squared, because that's my radius is 4. And so when I type that into my calculator, I should get type it in, 0.5 times 3.1416 times 16, 4 squared is 16, gives me 25.1328, but we have 2 of these, so I'm going to double that area. 2 times 25.1328, and that would be, and this was measured in meters, so this is in square meters. Since this is area, that's a square measurement. And so my area of my 2 semicircles, so times 2, would be 50.2656 square meters. Now let's work on the 1/4 a circle. So again, I know that the area of a circle is pi times radius squared, but since this is a 1/4 a circle, I'm going to have to do a 1/4 of that amount. So that's going to be a 4 times 3.1416 times, now we have established already on the other part of this problem that for this fourth of circle part, which is this part in here, that this in fact is not the diameter but in fact the radius. So this 8 meters is the radius of this fourth of circle here, okay? And so I'm going to say times 8 squared here. Okay, so I'm going to do 0.25 is 1/4 times 3.1416 times 8 squared on my calculator. And that gives me 50.2656 again, square meters.